So for question 46, we're asked to find the KSP of manganese hydroxide. Right, so manganese hydroxide would ionize to give us manganese 2+ and 2 hydroxides. And we're asked to find the KSP, and they tell us that the solubility of manganese hydroxide is 3.7 times 10 to the minus 5. So they've really given us enough information, and it's because my solubility of manganese hydroxide is 3.7 times 10 to the minus 5. That's telling me how much manganese hydroxide can go into the solution. So if my molar solubility for manganese hydroxide is 3.7 times 10 to the minus 5, basically that's saying my concentration of manganese in solution is 3.7 times 10 to the minus 5, because that's how much manganese hydroxide went in. That's my concentration of manganese. Because I'm going to get twice as much hydroxide, right? This concentration of hydroxide in solution is going to be, 7.4 times 10 to the minus 5, because it's twice the concentration that went in solution, because of that coefficient 2 in front of the hydroxide. So now we can find the KSP. My expression would be the concentration of manganese times the concentration of hydroxide squared. So my KSP equals my manganese concentration, 3.7 times 10 to the minus 5, times my hydroxide concentration, 7.4 times 10 to the minus 5 squared. So 7.4 times 10 to the minus 5, square that, and I multiply that by 3.7 times 10 to the minus 5. And I get approximately 2.0 times 10 to the minus 13 for that KSP. So just a little bit of a different variation in the problem we did in class, because instead of telling us, oh, the concentration of manganese is this, or the concentration of hydroxide is this, they told us instead our solubility of manganese hydroxide, and we had to use that to say, okay, if this much manganese hydroxide went in solution, right? If this much manganese hydroxide went into solution, I'm going to have the same concentration of manganese. And because of that coefficient 2, I'm going to have twice the concentration of hydroxide.